Hi, my name is Poppish, and I am here today to tell you about the chemistry behind nuclear explosions. But what exactly is a nuclear explosion? Well, you see, a nuclear explosion is an explosion that occurs during nuclear reactions, such as nuclear fission or nuclear fusion. What exactly is nuclear fission and nuclear fusion? Well, nuclear fission is when the nucleus of an atom is broken apart into two smaller nuclei, and it releases large amounts of energy. Nuclear fission is almost the exact opposite of that. Two smaller nuclei are combined together to form a new nuclei, which also releases a large amount of energy, but often results in a new element being formed. Here's a little brief history of nuclear explosions. The nuclear weapons that produce the explosions were first designed during the Manhattan Project. Some of you may be asking this right now. What exactly is the Manhattan Project? Well, you see, the Manhattan Project is a U.S. government military project that lasted from 1942 to 1945, and it produced the world's first ever atomic bomb. The atomic bomb that was designed during the Manhattan Project was tested at Trinity Site and produced the first ever nuclear explosion, and was equivalent about to 20 kilotons of TNT. The first official use of nuclear explosions were in the bombing of Hiroshima and Nagasaki, and this happened during the end of World War II. The chemistry behind the reaction's fission addition. As explained earlier, nuclear explosions occurred during the nuclear reactions such as nuclear fission and nuclear fusion. During the process of nuclear fission, the nucleus is being torn apart and a massive amount of energy is released. And this energy is what is producing the explosion. But how exactly does this work? What often happens during fission reactions is a process known as nuclear chain reaction. Nuclear chain reactions happen when the free neutrons from the first fission reaction are released and trigger more fission reactions, which in turn create a never-ending cycle. And these chain reactions will create a massive amount of energy, which will create bigger explosions. Here's a diagram of a nuclear chain reaction. As you can see, the neutron is hitting another nucleus, which is causing it to split, which is releasing energy, and even more neutrons causing those to split, creating an almost never-ending cycle. Here's the chemistry behind the explosions. Fusion addition. During the process of nuclear fusion, two smaller nuclei are smashed together to form a new element, and this process releases a massive amount of energy. The energy formed from this process is because the atoms are being smashed into each other at such high speeds that they almost rival the speed of light itself. They're going at such high speeds because they need to be able to overcome the electrostatic repulsion that keeps the protons from being able to connect to each other and bond together. And the attractive nuclear force always has to be stronger than the repulsive Coulomb's force in order for the nuclei to combine. Here's a nuclear fusion diagram. Here you can see two different isotopes of hydrogen, deuterium and tritium, are being fused together at high speeds, and it results in helium, a massive amount of energy, and a neutron. Here's some cool facts I learned about nuclear explosions. The largest nuclear explosion was from the Tsar Bomba on October 31st, 1961. The smallest nuclear explosion is from the W-54, otherwise known as the Davy Crockett. And another really interesting fact I found is that the swimsuit known as the bikini was actually named after nuclear explosions. You might be wondering how. And this is because the reaction of people seeing them is supposed to be a massive explosion like those at Bikini Atoll. And also, the average nuclear explosion would cause destruction in a 50-mile radius. Here are my sources, and thank you for listening.